So my name is Nick van Deerdonk. I'm the founder and CEO of RedLore. We're a company out of Ottawa. This presentation is basically split up into two parts. It's about smart offices and how they basically act as a Trojan horse to also fuel IoT enablement in buildings. And from the building automation side of things. So the presentation is in two parts. First, we're going to talk a little bit about the value drivers in the smart office, about the business case, and about the return on investment that our customers are seeking who are active in this space. The second part, we'll do a deep dive on the application that we did together with a particular customer of ours in the smart office. So you'll see what we've done, and we'll also talk a little bit about the challenges that we overcame, the problems that we solved, and the technology that we built in order to make this particular smart office application a success. So let me share my screen.
Yes, it's perfect. Thank you.
Okay, so just a few words about RedLore. We are an end-to-end IoT solution provider, and when I say end-to-end, what we do is we start from the sensor device. We build hardware devices with all sorts of sensors that correspond to the applications that our customers are active in. We build all that on top of the Wirepas mesh network. We've got a few years of experience with Wirepas mesh, and I must say that the experience has been a very fun experience and a very effective experience. And we found that especially the Wirepas's capability of offering a mesh network in combination with low power is a unique offering. The mesh is powerful because it basically means that you don't need to install infrastructure network, you don't need to install dedicated routers, you don't need to install access points, and still get full coverage in even very large buildings. It's immensely scalable. The application we're going to talk about in the second part of this presentation has installations with over 3,000 devices in one single building, and it's very robust and plug and play. So sensor devices, Wirepas connectivity, and we funnel all that data to a cloud IoT engine. And that cloud IoT engine is really where the mapping gets done between the devices on one side and the application on the other side. For example, we see that in most applications you have a natural hierarchy in the way that the devices operate in the field. For example, in a building, you have a room. A room can have one or multiple sensors. A room is part of a floor or a section of the building. Then you have the building level, which contains all those floors and sections. And you may have a site with multiple buildings. So at the IoT engine, all that structure is managed, and people are given access rights to certain parts of the data and not to other parts of the data. And then we also offer a dashboard platform that our customers use to build custom visualizations into, or they opt not to use that, and then we just funnel the data to their data system, to their visualization system, to their IoT application. So that's all good, and the IoT engine will support standard interfaces like MQTT, or via an API to give the application the full access over all that data and the data model. And last but not least is that we also offer deployment tools, like, for example, the smartphone app you see on the screen, but also tools that work in the cloud that help the customer to configure, change, reprogram the networks that are in the field, everything remotely, so they don't have to go in the field and change out things there. Our customers are are active in different areas. Building automation, office workplace. This presentation is very much about that, but also in logistics, supply chains, manufacturing, and healthcare. So let's talk a little bit about the smart office and the smart building. And I think one of the messages that we want to bring with this presentation is that it's really a continuum. Smart Office blends into smart building, and as we'll argue later, Smart Office is also a Trojan horse to get IoT applications that are more in the building space, to get those into reality. So let's dive a little bit into the objectives that people want to get with IoT and Smart Office and IoT and smart buildings. And those are not the same objectives. In the Smart Office, it's about improving employee well-being, improving employee efficacy. So to which extent can my people perform the tasks that they're supposed to do? And then on the third place, but in no particular order, is employee efficiency. How fast and at what quality level can my employees actually execute those tasks? Now, going down to the smart building level, there it's about comfort, where comfort in many traditional cases means temperature and relative humidity, building comfort. It's about the energy efficiency. How much do we spend every year on basically running this building and creating that comfort? And then finally, it's about ACM, asset conditioning monitoring. Is my rooftop cooling unit, is it running smoothly? Are there faults? Can we do preventive or preventative maintenance by preemptively detecting faults that will occur in the future? So the objectives are different, but if you look at the applications that live in the space of Smart Office and smart building, those really blend into each other. On the side of Smart Office, we have desk occupancy. Offices are moving to dynamic seating. People just pick a place, but they don't want to pick just any place. They want to pick a seat that is close to the people they will be working with that day. Meeting room occupancy, employee tracking, office asset tracking. Where is that computer projector? Where is that conference phone? Where is that demonstration kit that my colleague used the other week? Because I need it now because I have a presentation for customers. There is access control to the building. There is the HVAC, of course, and HVAC is moving more and more into air quality as well, and especially big corporates. They want to they want to assure that the right air quality is in the building, because there have been very convincing studies done that with the wrong air quality, like too high CO2 levels, that people's cognitive abilities actually suffer, and the efficiency of their work suffers, and a number of leading standards are gaining momentum there, like reset and well. And then there's, of course, lighting, emergency lighting, and energy management. So those are the applications we talk about that form a blend between the Smart Office and the smart building. Now, one of the arguments we want to make is that Office IoT is really driving IoT adoption in buildings. And why is that? So it's important let's look at the money side of things. Let's focus on the cost per square foot per year, or for the people in Europe who are accustomed to square meters per year. As a rule of thumb, just take the numbers and multiply them by 10, and you'll have a roughly accurate number of the costs of this building. So let's have a look. The first item is the energy. It costs roughly $3, say €3, per square foot per year to operate that building. The next item is the building itself, the real estate, the infrastructure, and also the maintenance of that infrastructure. Well, if you do the math, if you look at the numbers, that costs about 10 times more than the energy per year. So we're up to $30, 30 euros here, or 300 if you look at it from a square meter perspective. But then the third element is basically, what are you spending on your employees? What's the salary load of the people working in that building? And that's times 10 the real estate cost, and that's times 100 the energy cost. So the reasoning here is that if you want to save money, if you want to gain, then it's going to be much easier to work on the efficiency of your workforce than it is to work on the energy. 1% gain in workforce efficiency will amount to the full 100% of your energy cost. So we're not advocating at all to stop the work on saving energy, and that's not going to happen for sure. Energy is going to remain very high on the agenda in buildings. But if you look at it from where can I generate ROI in the quickest way by implementing IoT, then it's really in providing the right environment for people to work. So office workflows, workforce efficiency gains. How can we do that? What's important? What are the use cases here? Well, there's quite a lot of them if you dive into it. And just to name a few of them, know which colleagues are present and where they are. Today, I have an urgent question, and rather than shooting out an email and getting an answer maybe tomorrow, I'd like to talk to this person and have a one-on-one conversation, and hopefully when the whole Corona crisis will be over, people will get to appreciate the non-verbal communication and the strength of a physical meeting again. So another one is, where is that projector? Where is that demo kit? Where is that conference phone? I've been in meetings, and I think many people have been in meetings where that one item was missing, and 5 people, 6 people in the meeting were just waiting for that asset to be found before starting the meeting. Automatic booking of meeting rooms. How often does it happen that you look into the booking system and there's no meeting room available, but when you actually go to the meetings room, there's nobody there because the meeting was canceled, but nobody took the effort to remove it from the booking system. And contract tracing, of course. We're engaged with several customers in using proximity between people in building to actually give data, apply analytics on that data to give an idea about what the chances are that people that were contagious actually infected other people. And of course, the result of working on all these items is to increase employee well-being, and employees who feel well will also work well and will work efficiently and will like to work for the company. So now once Office IoT is implemented, once you got occupancy sensors, for example, under each desk, you basically got a pretty powerful Wirepas network that spans the whole of the building. And that network that's there actually acts as a Trojan horse for building IoT. So let's go into that a little bit. Building automation, and this is a little bit of a controversial statement, perhaps, but building automation tends to be, or traditionally was, siloed into closed verticals, very much dominated by large companies who solve all the problems and are not always very welcoming to integrate with other applications. So here comes Smart Office. And what we see is that Smart Office applications today are quickly being deployed on the corporate office floor. I think most corporates are, if not doing Office IoT, are thinking about how they can start doing it in order to increase employee comfort and efficiency. So there's 2 ways how this is acting as a Trojan horse. The first way is IoT devices for Office IoT often encompass more sensors than only those need for the application at hand. For example, all of the devices that we build measure ambient temperature because once you build an IoT device, you can, for almost no extra cost, you can add a temperature sensor. But there's more than temperature. There is humidity. There is light level, which is a very important factor in the office. Sound levels, and more, as I said in the beginning, air quality, things like CO2, volatile organic compounds, particle matter, And building managers, they wish to harvest that sensor data to improve the things on the building management side, not only on the office employee side, but side. Now, there's a second effect, a second Trojan horse effect, which is that the Office IoT network, the Wirepas mesh network, provides open connectivity. Wirepas has standardized the network protocol to such an extent that other devices that are not from the same manufacturer can actually integrate into the same network and can actually piggyback on that network that's already there. So what it basically does is it gives the other applications, the building automation applications, it gives them a platform, a communication platform that they can tap into without worrying about infrastructure, without worrying about things like is the wireless communication going to be reliable? Do I have sufficient devices? Because that's already there. It can piggyback on top of that. And it also allows building IoT applications to be deployed gradually rather than doing a big bang rollout, because they have that backbone network to build upon. And I've been in a few presentations earlier today, and I've learned that these two Trojan horses are not even the only ones. There's also lighting, which can be very successful in allowing other building IoT applications to join in. So from our standpoint, right now there is a revolution going on, and the thing with revolution is it's only after the revolution is done that you can actually see the magnitude of that revolution. But look at this rooftop cooling unit on the picture. Before IoT, so yeah, this rooftop unit is serving a large section of this building, really. So there's a lot of people that depend on the quality of this, on the quality and the good operation of this cooling unit. So before IoT, the only data points you really had was what's the supply and the return water temperature of this cooling unit, of this chiller? What's the water pressure? What's the flow? And what's the overall energy consumption for the whole area of the building that is served by this cooling unit? So we're spending $1 million on cooling a year, but we have no idea where that's going to, and we have no idea if this unit is actually providing the comfort that people are looking for. Yeah, we do get a few complaints from people now and then, but we don't really know what's going on. But if you put the infrastructure, the IoT in place, and if you have the backbone, thanks to your office application, Trojan horse, that allows you to add much more granularity. You can measure supply and return of the water temperature per fan coil unit at a marginal extra cost, because you don't need to put that backbone network there. That network is already there. Water pressure at every floor level, water flow at every fan coil level, energy consumption per fan coil. So if you have a heat leak somewhere in the building, then you will see that the fan coils that are close to that heat leak are doing extra work, and you can actually catch that, where if you don't have that level of granularity, you can't catch that. So the message here is that we're seeing huge changes in how buildings are being managed, and Office IoT is helping to fuel that change. So a few conclusions before we move on to the use case. IoT, it's not only about reducing the wiring cost, it's about interconnecting applications, really. It's about using the data across to other applications than where it was meant for. Real estate owners, facility managers, they want to increase their insights in how buildings are performing. And the incumbent building automation suppliers are now starting to see that integrating independent IoT data sources increases the value of their offer. If they have information about temperature at the desk level, they can actually improve their temperature control algorithms to provide better comfort to the people. And very important, to to keep on fueling this growth is interoperability. And we see interoperability at 3 levels. First, the Wirepas mesh provides interoperability at the level of the IoT sensor network. The gateway has the role of, or can play the role of, connecting to networks. So we get asked, do we need to throw out our backnet network or our RS485 devices? They're there for a long time. We don't want to replace them. No, not at all. That's where the gateway can provide the interface to those traditional systems and to even inject the data in those systems if required. But the most efficient place to aggregate the data is in the cloud and share that data across applications using standards, open standards like MQTT, or using an open API. So now a use case that we did together with a customer who's one of the leading players in the space of workplace utilization. Now, why is workplace utilization important? There are a couple of reasons to note. First of all, to reduce the real estate costs. Today, or before the corona crisis, the office space utilization was around 50%. The problem is, where is that excess 50%? And on what floor, in what division? Where can I rationalize? Second element is improve employee experience and productivity. Today, it's about dynamic seating, allowing people to choose where they want to sit next to the person they're going to work with, stimulate collaboration with people, but at the same time, allowing the people the privacy of a closed phone booth or small meeting room if they have calls that are better done in privately. And thirdly, it's to create and implement a more effective workplace strategy. Things like hoteling, multinationals who have people all over the world who from time to time move to another office for a few days for a particular reason. Well, those people want to be able to book a space for 2 days, 3 days. Other companies or other divisions in that multinational have a totally different use case. They have high churn work sessions, half an hour, 1 hour, going quick from one meeting to the other. So that's another use case, and that's where the IoT helps you to generate that more effective, more efficient work environment. So what's the solution that we implemented together with this customer? Every desk and every meeting room seat receives a sensor device. You can see a device like that at the bottom left. It contains multiple sensors because in this application we discovered that in order to get the accuracy right, to get a very high accuracy and limit the number of false positive detection and false negative detection, we need to combine some sensors and apply some proprietary detection algorithms. And all that data gets ingested to the cloud, and our customer built some smart visualization dashboards on top of that. And in the middle picture, you can see such a picture where the color indicates whether a place is occupied or not. And at the right, you can see an application they developed specifically for COVID tracking that actually gives you, helps you to detect where the risks are, and that can give you retroactively information about the proneness of your environment to spread the disease. And it's obvious to see that even when the corona crisis will be past us, that this will very likely remain on top of the priority list of big corporates. So what have we learned in this project, in this case? So we've together with the customer, we've scaled this from buildings, environments with a couple of hundred of these sensors in one building to environments with thousands and thousands of devices in a single building. So naturally, the first important requirement is that the technology scales, and that's where Wirepas comes in, and that's where it really works out of the box. Second thing is zero network planning, low infrastructure. The people who install this, and this is a difference between a POC, a proof of concept installation, and large scale rollout. That's really where you can't rely on a certain technical level of the installation people. You don't know who's going to install it. It's not going to be you. It may be professional installation companies. Maybe the customer is going to do it himself. That's where we advocate the IKEA philosophy of make it very easy to install. Don't require that the customer knows how to plan a wireless network, and the Wirepas network is built on this philosophy that it will automatically self-form, and self-heal. Another thing that we discovered and built as we were scaling up is you need a solid IoT backend system. If you have a proof of concept or a pilot installation with 100 devices, it's basically a flat list of 100 devices. It's easy to manage. You can put all those devices easily on a one-page floor plan. And if something goes wrong, you can just walk up to that device. You know where it is. That doesn't work if you have a large installation. There you need to introduce the idea of our object hierarchy of devices installed in this room and not in that room. You need to come up with strategies to do device provisioning. This device comes out of the factory. It's going to be installed in that network with those security keys, with that network address. How do you manage that? And we've come up with tools. We've built tools to help the installers do that. Large installations in buildings that are occupied need to be done during the weekend, overnight. So it has to happen quickly in a finite amount of time. And that's where coming up with these tools and installation strategies is very important. Access rights to dashboards is another element here. Network health monitoring, and finally and importantly is device configuration management. And this goes back to the argument that other applications will want to have some of this data. So at some point you may decide to turn on the humidity sensor on the device that was not configured to do that previously. So that's where the IoT backend system should be able to talk.
Nick, we have a 1 minute 20 seconds.
Okay, thanks. I think we're almost at the end of it. Predictable long battery life, sensor edge analytics. Maybe that's one important last element I want to mention is if you want to go to scalability, you need to make sure that the network supports that large amount of devices, which also means that the devices shouldn't be flooding the network with data. And that's where we moved a lot of the algorithms to the device themselves, so that they can do the detection by themselves, and they only really have to send out messages when an event is detected rather than send out raw data. So with our sensor edge analytics engine that we have on the device, we allow our customers to build their own algorithms on the device itself. And apart from allowing scalability, it also drastically reduces battery life and reduces communication costs in case you're using cellular modem.